Welcome to Online Maths TV. Here we are again. We have a system of a simultaneous equation. If we take a critical look at this simultaneous equation, it's not your normal or your usual simultaneous equation you normally have. Okay, so I'll be solving this simultaneous equation using two different methods. Okay, now the first method might be familiar to you. The second method is a bit unfamiliar. So I urge you to stay till we get to the second method. But let's take the first method by taking our solution first. So we have your solution. All right. So we put on our question, which is y to the power of 2 minus x to the power of 2 equal to 1, and our y to the power of 2 plus xy equal to 2. What I will do here, I will call this equation 1 and this equation 2. All right. Now, if you look at equation 1, we can derive an algebraic identity from here. Remember the law, which says that if you have your a to the power of 2 minus b to the power of 2, this is equal to your a plus b close bracket, bracket a minus b. Okay? This is what we call difference of 2 squared, right? So we can apply it to this other side. In equation 2, y is common to these two expressions. So we can factorize y out here. So rewriting equation 1 and 2, we can have this to be your y plus, this is plus please, x close bracket, bracket y minus x close bracket. This is equal to 1. Okay, then here we now have this to be y bracket your y, because if you use y to divide this, we are left with y. Then plus y into xy, we are left with what? X. The close bracket, this is equal to 2. So let's give this equation 3 and let's give this equation 4. Good. Now, if you look at equation 3 and 4, we can do something from here. Divide equation 3 by 4. So from here, we want to divide equation 3 by your 4. So if we do that, what will become of this expression? Let's continue on this side. We have our y plus x, right? Close bracket, bracket y minus x, close bracket, all over. We have our y bracket, your y plus x, is equal to 1 all over 2. What happened? What we have here, we also have it down here. So this will leave. So we are now left with y minus x all over y equal to 1 all over 2. So what we do here, let us cross multiply. So if we cross multiply, we're going to have this to be our 2y minus 2x equal to y. We use this 2 to multiply everything here. We use this y to multiply this. Well, all right. So let's collect our lightest. Move this to this side. So we're going to have 2y minus y equal to our 2x. Simple. So 2y minus y will give us what? Y is equal to 2x. Let's give this equation 5. Good. Now that we have this to be our equation 5, what do we do next? Put equation 5 into either equation 2 or equation 1. But here, let's put it into equation 1. Okay, so if we say put equation 5, put equation 5 into equation 1. So what to put wherever we have y in our equation 1, let's write equation 1 first. We have y squared minus x squared equal to 1. So wherever we see our y, we put in 2x. So this will now give us here 2x all squared minus x squared equal to 1. All we need to do is just to open up this now. So if we open this, we're going to have here 4x squared minus x squared equal to 1. Let's continue on this side of the board. So we have here 4x squared minus x squared will give us here 3x squared then equal to, here we have 1. So we can look for our x here now. Divide both side by 3, divide both side by 3. Cancel, cancel. So we now have x squared equal to 1 all over 3. At this point, what do we do? Take the square root of both sides. So if we take this, we equally take the square root of this side, and we introduce our plus minus. Remember? Yeah, so this leaves the system. So we now have x is equals to plus minus the square root of your 1 all over 3. Now, the square root of 1 is 1. The square root of 3 will still remain 3. So we can go ahead to rewrite this expression as 1 all over the square root of 3. Easy. If you want me to work further, we can still rationalize the denominator. And if we do that, look at what we're going to come up with. So we're going to have x is equals to plus minus root 3 all over 3. Is anyone confused? You know how to rationalize this, right? Look at what I did here. I just said 1 all over root 3. This is equal to your root 3 times 1, okay, times 1 all over root 3 times root 3. Okay, so if we go down, this will give us root 3 all over root 3 times root 3 will give us root 9, which is what? 3. That's how we got this, right? So we are having two answers from this place now. Here we are having plus root 3 all over 3 and minus root 3 all over 3. So we've gotten the first and second value for our s rather. We've gotten the first and second value for our x. Now that we've gotten the value for our x, which is x1 and x2, then what do we do? Let's go back to equation 5. We cannot put these two values into equation 5, where we have our y as the subject of the formula. Okay, so we cannot say here, substitute x into equation 5. We bring down our equation 5, which is y equal to your 2x. So wherever we see x, let's go ahead and put in these values. To save time, let's just put the whole of this into this. So we're going to have this to be a y equal to your 2 into plus minus the square root of 3 all over 3. Easy. So again, if we use this to open up this, we're going to have, therefore, our y is equal to your plus minus your 2. Let me write it well, 2 all over 3, okay, then root your 3. This is the value of our x and y. Okay, so if we are to look for our xy here, so we have x1 comma y1 is equals to root 3 all over 3, then comma 2 all over 3 root 3. Then your x2 comma y2 is equal to minus root 3 all over 3 comma minus 2 all over 3 root 3. Clear? All right, so let's go over to the second method, which I said is a bit unfamiliar to you. All right, although it might be familiar to you, but let's take the second method. Let's put our question again. So we have y squared minus x squared equal to 1, and we have here y squared plus xy equal to 2. Now look at the crazy thing we want to do here now. At this point, I want to say let y be equal to let's say mx. Okay, let y be equal to mx. So wherever we see y in equation 1 and equation 2, we put in mx. So let's take this. So this now implies this first equation is going to give us here mx r squared minus x squared equal to 1. Then again, we have this here. So we have mx r squared plus your x into your mx close bracket equal to 2. So what we do here, we cannot open up this now, right? So if we open up this, then this will now give us here, or this now implies we have here m squared x squared minus x squared equal to 1. Then this other side we also have m squared, okay, m squared, the x squared plus your x squared m equal to your 2. Any confusion? Okay, so from here, see what we want to do now. We want to factor out x squared from here, also factor out x squared from here. So let's continue on this side. All right. So the first one, if we factor out x squared, we're going to have here x squared into, here we'll be left with m squared, then minus 1, close bracket, equal to 1. Easy. We do same thing here. Let's factor x squared too. So we have x squared, here we have bracket, your m squared, then plus your m, close bracket, equal to 2. Easy. All right. Now, make x squared the subject of the formula here. Make x squared the subject of the formula here. So this now implies your x squared equal to 1 all over your m squared minus 1. Let's take this as our equation, and let's take this as 3, because here we are having this as 1 and this as 2 already. Then here we also make x squared the subject of the formula. Your 2 all over your m squared plus your m. Let's take this as our equation 4. Simple. All right. Now that we have our x squared is equals to 1 all over this, and we have our x squared is equal to 2 all over this, x squared. So we can now equate equation 1 and equation 2 together, okay, to each other rather. So if we equate equation 1 and equation 3 and equation 4, so we're going to have 1 all over your m squared minus 1. This is equal to your 2 all over m squared plus m. All we just need to do is just to cross multiply here. So if we cross multiply, we're going to have m squared plus m equal to 2m squared minus 2. Collecting your like terms, what will happen? So this will give us here your 2m squared, okay, minus m squared. All right. Okay. Then here we have minus m, there minus 2. Everything equal to 0. Are we in order? Yes. I move everything here to this other side of the equation, which is 2m squared. This minus this crosses the sign of equality, turns to minus m squared. Then this crosses to this other side, turns to minus m. There our minus 2 already here, equal to 0. Any confusion? No. All right. Again, we can carry out a simple arithmetic here. So 2m squared minus m squared will give us here your m squared, this m squared, then minus m minus 2 equal to 0. What comes to mind, what we see here now automatically is a quadratic equation because the highest variable here is 2. So let's solve this quadratically. Can we solve this using the factorization method? Yes, we can solve this using the factorization method. If we bring out the two factors of 2, we have 1 and 2. Okay, so we just have 1 and 2 that we fit into this. What will be their signs? Okay, this will be minus and this will be plus. So plus 1 minus 2 will give us what we want here. So we can solve this using the factorization method. So let's continue on this. All right, before we dive to this side of the board, we still have some space here. So let's write down our expression. So we're going to have here m squared, then minus 2m plus m minus 2 equal to 0. So we can put this in bracket, put this in bracket, put this in bracket, put this in bracket. What is common here? Here we have m, and here we have what? 1. So if we do that, we're going to have this to be your m into m minus 2 bracket plus, what is common here? We have 1. So we have 1 bracket m minus 2 equal to 0. Okay, good. So from here you discover what we have in this bracket and here they are the same. So automatically we have here m minus, let's take plus 1 first, into your m minus 2 equal to 0. So from here we apply the zero product rule. I've made use of this zero product rule in so many of my challenges, solving some of my challenges, okay? So what does that zero product rule say? It says that if you have your A dot B equal to 0, it simply means that A is equals to 0 or B is equals to 0. Remember this law? We call this the zero product rule. Okay, so if we apply that here, so we have here m plus 1 equal to 0 or m minus 2 is equal to 0. So we have m is equals to minus 1 or m is equals to positive 2. So we have here m is equals to minus 1, comma 2. Now if you look at this challenge very well, you're going to discover that this solution minus 1 will be rejected. So we cannot say, therefore, your m equals to minus 1 is rejected. This one is rejected. Okay, so if we reject this root, we are going to make use of only this second one, which is 2. All right, so for us to make use of 2, what we do, we come to either of these two equations, either equation 3 or equation 4. But let's take the first one, which is equation 3. So we can now say, put m equal to 2 into equation 3. Let's put it into equation 3. We write out our equation 3, which is x to the power of 2 is equals to 1 all over your m squared minus 1. Substituting, this will give us 1 all over your m is 2. Yes? Okay, so we have here 2 squared minus 1. So we have x squared equal to your 1 all over 4 minus 1, which is equals to 1 all over 3. So again, we take the square root of both sides. So the square root of this is equal to 1 all over 3 square root. Then we introduce our plus minus. This goes with this. Do you see it? We're almost there. Okay, so let's go to this other side of the board to get our final answer. We're going to have, therefore, our x is equal to the plus minus the square root of, now, like I said the other time, this will give us 1 all over the square root of 3. And again, if we rationalize this, this will now give us here root 3 plus minus, you have your plus minus root 3 all over 3. So if we rationalize the denominator, we'll come up with this, which is same answer, same result we had in the first method for the x value. Okay, now how do we now get our y value from this expression we have here now, from m is equals to 2 and x is equals to this? So recall, there's a place where we said let y be equal to mx. Remember? Good. So from here, we now say recall, we said that let y be equal to mx. We calculated for the value of m, we've also calculated for the value of x. So let's go ahead and solve for our y. So we now have y is equal to, what is m? We calculated our m to be 2. So we have this to be 2 into, what is our x? We have our plus minus the square root of 3 all over 3, close bracket. Again, if we open up this will give us plus minus 2 all over your 3 to the square root of 3. Okay, so in all, what are the two possible values of our x and y? So we now have, therefore, our x, what is happening? X 1, comma, y 1 will now be equal to, the first value is what? Your plus, which is just root 3 all over 3, comma, then plus your 2 all over 3 root 3, close bracket. Then our x2 comma y2 will now be equal to, so we have bracket minus the square root of root 3 all over 3, the comma minus 2 all over 3, the root 3, close bracket. All right, so these are the two possible pairs to our simultaneous equation. All right. So this marks the end to this wonderful simultaneous equation using two different approaches. And I want to believe you must have learned something from either the first approach or the second approach. Again, this is All I Must TV, and my name remains Jakes Anemo. Thanks for always be there. Remember, Jakes loves you, and every one of us at All I Must TV loves you because you are always there. Again, if you learned something good from this challenge, from this video tutorial, drop it in the comment section. It could be thanks, Jay. It could be, hey, you made an error or you made a mistake in trying to manipulate this aspect. Okay, we are good at responding to our comments. Okay, so that we can equally learn from you. So it's expected that you just leave a comment down below. If everything is clear to you, then say wonderful. Okay? Again, we love you because you are the reason for this channel. Bye for now.